few people will be there in the class, so we are not going to learn something new today. What we are going to do, we are going to discuss on whatever we have discussed so far, and we are going to solve the numerical connect. Because I think today is the right forum to discuss this very specific numericals on top of the algorithms that we have discussed. So the first things first is just to recap on what we are in stand. So we have discussed about the polyalphabetic ciphers in terms of Vignere cipher using a table as well as the non-tabular approach. The non-tabular approach will not be there in the PPT, it is there in the course material which I uploaded. There the methods have been mentioned. But ideally the method is very simple in a way that we are going to utilize approach where we are going to replace each and every cipher plain text as well as the keywords with respect to the respective numbers. We will form a table, and from that table we are going to use this equation that is mentioned over there as the plus equation or the additive cipher equation, pi plus ki, and based on that whatever the numeric equivalent remainder we are getting, we will consider that as the cipher text, and based on that we have solved one numerical in fact last this class. So that's where maybe we can start off, at least for the time being. So let me brief on whatever we have discussed, then I'll come back to the numerical testing. The next one that we have discussed, and that was in fact the majority of our discussion, and that was the Playfair Cipher. And this is a cipher in which we came across that the first time we are making sure that there is a 5 cross 5 key matrix, and based on that we were designing the matrix in a way that no unique letter, like every entry will be a unique entry, and even if there is a repetition of any of the letters, we are going to omit that. Since it has been already been used, we are not going to repeat that in the existing table. Based on that, we took an example where monarchy was the key, and based on that this was the key set that we have developed. And if you observe, one of the assumptions was that I and J will be clubbed together, and we are going to use that all throughout our discussion and for the other examples as well. And along with that, we have also taken Pascal as one of the examples for a keyword where A was repeating twice, and in that I told you that A, as it is already there in PA, so where in the next time when the A appears, we are going to omit that, and only then we are going to have this 5 cross 5 matrix together. That's a rule, and that's even if we will see another numerical today itself where the same applies. So based on that, the key sets will be developed, and then based on that we are going to use some kind of a rule. And one of the first rule was, as I said, the first rule was not related to the key. It was primarily based on the plain text, that if we are receiving a plain text, the rule for Playfair cipher was that we have to break them into diagrams, 2 alphabets together. And if in that case, if suppose there is a repetition of number of digits or alphabet, then the first alphabet will be substituted along with that, an X or a Q or Z sometimes. So those low probability appearing symbols. And based on that, we have considered that this is one of the examples where you can see balloon, in that the first L is suffixed by a L X, suffixed by an LX, whereas the next L is going on with O. And also you can see that as we are considering the first repetition of double L, for the double O we don't need anything, because O is now a unique pair with N and a unique pair with L also. So then we don't need that double O to take care of. Similarly for hello also you can see HALLO. For the first L we are considering LX, whereas the next L is clubbed with O. So this was with respect to the plain text. In fact, we took an example of instruments where we have observed that the last S, if I go back to the example, so in instruments we are observing the last S that we have is a single entry. So in order to make it dibit or diagram, we are including a Z over here just to make it, we are suffixing an S to make it 2 alphabet together. Because that's the basic rule, right? So that's the first rule for the plain text, and the rest 3 rules are applicable to the key set that we have developed. In that, the second rule was that if suppose the plain text or the dibit that we are considering, the 2 alphabets that we are considering, if they fall in the same row, then very simply what we are going to do, that each and every alphabet will be replaced by the very next alphabet which is there in the right hand side of the same row. So based on that we have found this, and the second one was with third one was with respect to column. If they appear in the same column, the same thing will apply, that it will go downward and we are going to replace by the next letter which is present in the same column. And even if it is a wraparound condition, we are going to go ahead with the wraparound condition as well. And the last but not the least, the last rule was that if at all it doesn't fall under the two categories, that it doesn't come under the same row, neither it comes in the same column, then wherever the two columns intersect, wherever the two alphabets intersect in two different rows or two different columns, that will be considered as the entry as a cipher. And in that example, I told you some of the example, like for example, H and S. So H lies somewhere in the second column, which is somewhere over here H, whereas S is in the third column, which is over here. So there is no such common entry with respect to any row or column. What we have to do is, since H has appeared first, so we are going to go towards the right. You can see over here, and B is the element where it is going to intersect with S. If you go on extending this S axis or X column, B is the element where both these two intersect. So we will consider B as a replacement for the letter H, and for S we are going to go left hand side, and it indicates that P is the entry where it is getting intersected. So for the die bit H and S, we will substitute that by B. Alright, so this was the basic discussion that we have discussed on this class as well. And following that, we have discussed a particular example where instruments was the plain text and we had monarchy as the key, and based on that we also had taken the reference of this particular table which we had already formed. So based on that we found out that what are the necessary key, the cipher text which will be developed after a certain period. So this is where we ended up our discussion. So today's class we are going to utilize all this knowledge itself, and we are going to solve a few more numericals on this. We are not going to start with a new algorithm today since the lack of number of students today. Right? So the first things first, let's suppose for example this is a new example, Playfair example. Okay, so this is the key. The total thing that you are looking at is the key. Alright, so if you observe that what we have done, what I am trying to mention over here is that play, you can see P-L-A-Y, play, as A has already appeared, so F is also a new element. But now if A is there, like we have discussed for the Pascal, here Playfair, if I consider that A is not repeated over here, that's why it is mentioned as red in small. Like as if it is there, but we are omitting it out. So that's why this particular arrangement, you can keep a note of it because the next question will come in with respect to this only. So Playfair, this is what we call as a key set. So Playfair example is the whole word or the key that we are considering, and based on that if I arrange it into 5 cross 5, this will be the necessary arrangement. Okay, just check it once before writing it also, that why it is correct or whether there will be any changes or not. Those red color mentioned lines are just to give you an indication that those are the elements which already appear, so we are not going to use it. So that's why they have been mentioned. Don't get confused with that. Okay. So suppose you have this particular key arrangements with you. Okay. The first question that comes in, is it taken already? I'll switch up to next slide. So now using this key, find the encrypted message or encrypt the message, or find the cipher text for hide the gold in the tree stump. This is the plain text. The plain text is given by hide the gold in the tree stump, and you have the key set as the Playfair example. Please take your time and finish it off and show me your final answer. The key set is Playfair example. If you have not copied the previous also, you can write it down right now. Start with P-L-A-Y and then the same logic you apply and make the 5 cross 5 matrix, and then use the plain text hide the gold in the tree stump. Ignore the space that is there in between the individual word and make it happen. I'll give you some time to finish it off, but do it correctly. Pairs, when you are dividing it into two letters, this is the plain text. One of the changes you can observe key, where it's mentioned as 2E. One is considered as EX, the other one is ES. So that is one of the observation. This is your key that we are talking about. So let me know if you are ready with it. We'll verify it first here, then I'll give you the answer. I'll do one thing, we'll write it one by one, like HI, like that. Answer. So HI, tell me. VM. OD. ZB. Okay. XD. Okay. NA. So for the time being, I'm writing because I heard another answer from here. NA, then BE. Okay. KU. DM. Sorry? UI. XN. M. This one ES. MO. UV. IF. I don't know because the next slide will have the answer. But before going to that, can you see a very interesting observation over here? Hopefully this is correct with the process that you are looking at. Can you observe one thing? If you go by the frequency redundancy that we all know as per the cryptanalysis, you check here E, the letter E is substituted by something like an X, whereas the next E here is substituted by something as M. Okay. Another thing you can see here again, E is substituted by M. Here E is substituted by something like an X. Again, some E over here is substituted by D. So there is no common pattern. What I wanted to convey over here, that there is no common pattern that you are observing for each individual letter. That is one of the key aspects to this polyalphabetic cipher impact. That there is no one-to-one mapping, but there is one-to-many mapping that might happen. So definitely the frequency analysis based attack will be difficult for a Playfair cipher for the man. We'll come to that post your vacation. We'll do that later. But just an example. So maybe this is the final answer. So let's see the NA is correct or not. Yes, it is correct. Okay. So I can skip this step, that how we are going to find it out for people. Anyone having a doubt how we are going to do it? This will be there in your course page, but I think it's waste of time to go through it once again. I guess instead of that, we can skip in one question instead of that. Any doubt with this? No. Now quickly finish up this one, then we'll go on to the other example. Suppose you have a secret key which is like this. Secret key means a 5x5 matrix is provided to you. Please make a note of it. The key directly is not mentioned, but a key matrix is provided. The question is encode the message hello. Even there, very quickly you can finish it off and tell me the answer. Done? Very good. Okay, tell me the answer. So I think I have the answer directly, so maybe we can check it. So it's ECQZ BX, and the same LX has been considered for dual letters. If you are agreeing with this, can you do quickly the last problem on Playfair? Construct a Playfair matrix. I'll just dictate the answer question to you. Construct a Playfair matrix with the key occurrence. The key is given by occurrence. OCCURRENCE, and encrypt the message Merry Christmas. Key is occurrence and the plain text is Merry Christmas. Please finish it. As I already have told you many times that this algorithm, the steps are absolutely the same, except that by practice you can use multiple such keys and you can generate any single question which will have the different answer. But the method will be same for all these questions. So please remember the process, how it is being done. So more you do it in this way, in this case particularly you can observe that there are many repeating letters is there in the key. So that makes things a little bit difficult. So key is over here occurrence. So it starts as per our logic. It will start directly filling up the left hand column, the first one. So OC, occurrence as a spelling, OCCURRENCE. So the first C, as we have already taken, the second C we are going to opt out. So we don't need that. So the next entry is U, then R. The next R again we are going to omit because that is again repeating. E, N. Next. People at the back, please can you tell me the next entry over here in the table? Okay. So C and E has already appeared. C and E already appeared in the first row itself. So we don't need that. So we start with A, B, D. D. Girls. Next entry. After D. F. Next. H. I and J will be together. K, L, M, then Q, V, W. Very good, thank you. So this is my key set, and the plain text that we have is Merry Christmas. So that if I divide into two halves, each two letters, can you go on dictate me what it will be? Any, then RX, RY, CH, RI, ST, MA, S. Good. And the code word? UY. Next? ER. UK. PM. PM or N? I have one question here. RI, can you check RI once? UK. R is where? Okay. And I is somewhere here. So R has appeared first. It goes here. I has appeared over there. So this is basically the way we are going to go for any Playfair text algorithm like ciphering process involved. The cryptanalysis of Playfair we will discuss post our we come back. Okay. But before that, before we conclude the session, let us discuss some more questions on the other algorithms that we have discussed so far. I found this question pretty interesting, so thought of sharing this with you. Please make a note of it. I'll write it down. Otherwise, see the question here. The cipher text, a cipher text has been generated using an affine cipher. Affine cipher, remember? What was the feature of affine cipher? Why was affine cipher used? Like, what was the feature? There was an additive and multiplicative cipher together. So basically, there were two keys that we considered. Okay. So the pair of keys. So a cipher text has been generated using affine cipher, and the most frequent letter of the cipher text is F. Most frequent letter is appearing in the cipher text is F, and the second most frequent letter in the cipher text is S. Oh, sorry, C. Sorry. The question is, find the pair of keys. Just this much of information you have. Or sometimes we also mention break the code in that way, synonymous. You have this only information that an affine cipher has been used, and the most frequent letter that has been used, or the alphabet that has been used, is F, and the next is C. Find me the key set or the pair of keys which might have been used to encrypt this message. Can you take 5 minutes to think of, or 2 minutes to think of, and give me a logical answer on how we are going to find it out? Cipher, those are two most frequent. Correct? Any answer to this? What would be the first assumption that you are going to make? Because the first letter, the F, is the most frequent. So this is the cipher text we are talking about. So we can merge this with the idea that the most frequent letter F can be merged to E, or can be mapped to E, because we know that from English alphabet E is the maximum or the most frequently used, and E is having 4 from the table as a numeric equivalent to it. So let us quickly point that thing out. And also for this one we can assume that to be T, because we know, sorry, this is 19. Okay, so that those were already discussed in previous example from the table itself. So this is the information that we have. Next, what to do? Remember that we need two keys K1 and K2 which are unknown. Then how to proceed? I already got one answer from here. I want a few more answers of the same nature. What was the equation for encryption? C equals to, cipher text equals to P multiplied by K1 plus K2 mod of. So this was the equation we used. Now if you observe that we are going to use this equation itself to solve this K1 and K2, because we know about C, we know about P, okay, we don't know about K1 and K2. But there are two instances that we know of, 4 and 19. So the process involved is that we can assume any plain text, rather we will not assume any plain text, to be honest. We are going to assume any cipher text which has come in over here. For example, your cipher text over here is F, which we will write in this way, C, because this already we have assumed it to be with E, so we are writing it as 1. Let me just give you this one. Alright, let me just reframe myself. Alright, let us take any two letters from the table. Any two letters. We know that F and C might have appeared in ciphertext, maximum and the second maximum. The logic is we will take any two other letters from the table that we come. 1 equals to 4 multiplied by K1 mod of 26, and the second one we are writing 20 equals 19 multiplied by K1 plus K2 mod of 26. This could have been any other letter in the left hand side as well, but this is just a two extremes. We are taking 1 and 20 for that matter. Now the logic is simply we have to do the modular subtraction, which happens to be very similar to that of normal subtraction, algebraic subtraction, and we can solve these two equations and get K1 and K2. So simply you can substitute. See, if I consider this as equation number 1 and if I consider this as equation number 2, so if you subtract 2 from 1, or rather 2 minus 1, if you are doing it, then basically we are getting an equation 19 equals to 15K1 mod of 26. Now the logic is simple, that we have to consider any arbitrary value of K1 such that the remainder matches to 19. K1 should be such that, because 15 multiplied by K1, suppose 15 multiplied by 1. So 15 mod of 26, will it be equal to 19? No. If 15 multiplied by 2, so then 30 mod of 26. No. 3. Okay. 45 mod 26. That is 90. So K1 is 3. So that's how we are going to do, nothing else. So the trial and error method, we substitute different values of K1 such that this equation remains. Remember that the left hand side, what you are looking at over here, like the 19 over here, is nothing but the remainder that you want to have. So whatever be the value of K1 such that by multiplying with 15 and dividing it by 26, the resultant remainder will be 19. So you can where is the plain text? Acha, okay. Oh. E to become B. Okay. Yeah. Correct. So in that case, the initial assumption becomes wrong. So in this case, suppose K1 is 3 and K2 will come as 15. Right? So 3. Okay, 1 minute, just give me 1 minute. E is, suppose I consider K1 as 3 and K2 as 15. Now if I substitute in the first equation itself, 4 multiplied by, plain text is assuming 4 into 3 plus 15 mod 26. अच्छा B, अच्छा ओके ओके अच्छा in fact you will observe here there is a problem with this which I was coming to. See, this question is taken from tallies itself, but you can see the key is 3 and 15, right? But can you see this, that for a decryption it is not possible in fact. 3 and 15, if you take GCD, it's that is what. See, the solution that I made it with respect to the question given in tallies. I'm coming to that 315 if you are taking, you don't have any multiplicative inverse of it. Can you see that in affine cipher the K inverse? So you need a multiplicative key in order to decipher it. So 315 cannot be the key, to be honest, as per their assumption. That's where I was coming to. Yeah, that's what. Like the question I think should have been the question is that check that whether the key 3 and 15 is a valid key for an encryption of the sort. That should have been the question. But if you go to Stallings and you check the question is something like this only. The one that I told you. So when you solve it, you find out that basically 3 and 15 cannot be the key, as it is not satisfying the very condition of multiplicative inverse. Guys at the back, please, can you understand this? What we are talking about? We are observing over here, which is rightly pointed out, that if we are using K as 3, K1 as 3, and so those assumptions should also be provided over here. This is using Vignere cipher, okay, without the table. The question is, use the key code CODE, okay? CODE. Use the key code to encrypt the sentence to be or not to be. So the plain text is given as this, and the cipher that we are going to get has been given in this form. So plain text is to be or not to be, whatever be the key I am not mentioning over here. Cipher is given as V F R. So this is the format in which the question is given. Your plain text is to be or not to be. Your code is key is code, and your cipher you are getting of that nature. Use the Vignere cipher to find out the full cipher letter, like cipher text. Without using the table, use the Vignere cipher to find out the cipher text. Remember the process for Vignere cipher? The length of the plain text as well as the length of the code or the key should be of same dimension. And if you have to make that of same dimension, you have to repeat the key again and again. So in USIGNAT process, without using the table, form the cipher text. In that few reference cipher text is given. Cipher letter rather is given. Anyone? Guys, all of you ready with this? Anyone? What should be the cipher text? V E I Q F then So this is also a way of doing it. And in this also, one thing to note, if you observe very carefully, that when you take the plain text E over here and the plain text over here as E, for this one it is mapped to I, whereas for this it is mapped to G. So the same problem, the same solution to the frequency analysis attack that I was talking about, that the individual letters might not be mapped to a single entity, but there can be multiple occurrence of the alphabet. So in that way we can avoid the frequency analysis error or to improve the security of the encryption. Alright, so similar kind of questions are there in the material also. When I upload, you will find that there are some other ways of finding out the keys also, which due to time I might not be able to do it next when you come back, but at least you can go through it, and similar kind of questions you can expect in your exam. Fine. So we'll come back after the vacation and we'll start off with the next set of algorithms. Okay? Thank you.